Hi everyone, welcome to another linear algebra tutorial. In this tutorial, we'll be learning how to find the particular solution and also the solution set of the homogeneous system. So we will go through a few examples to take a look. What do you mean by this? So now we have already done like earlier on where we actually solve a system of linear equations and then expressing the solution set using vectors. So now from here we can continue, we can identify which part is the particular solution, and hence also we can identify the solution set of the homogeneous system. So I guess earlier on in our lesson we have already covered these parts. So I will not go into detail the working of how we actually get the solution set. I will just release the solution set first. So for the first one, the solution set is written in this form. So this is the solution set using vectors, as you can see here. So now we will slowly, this is our solution set for x and y. X is 6 minus 2y and y equals to y, and hence we will do it in vector notation in this form. And as you can see, since it has a free perimeter which is y, therefore the system has infinitely many solutions. And hence, so now as you can see, for a general equation which is like this, you have the particular solution, but the particular solution means that it's free of any free perimeters or any non-leading variables. And this part here, the minus 2 and 1, is the solution set of the homogeneous system, which means that it has a free perimeter. So now let's take a look at the particular solution is hence written as 6, 0. This particular solution is independent of any free variables, which is y, and hence the solution set is written as this: minus 2, 1y, where y is any real value. And from here you can see that this solution set has many vectors, including the 0 vector, should y be, because y can also be 0. Hence, this homogeneous system is consistent. Let's take a look at another example, which is this. So the solution set is written using vectors as this. As you can see, this solution set is one element. Since there are no vector of 0, this system is not consistent. Hence, we only can get the particular solution, which is written as this. And there's no solution set of homogeneous system since there are no perimeters. Now let's take a look at the third examples. Our solution set using vectors is written as this. And now we will make it in vector notation, which is written as this, where x3 is my non-leading variable or the free perimeter. And as you can see here, the system has infinitely many solutions. And this is, so again, our equation, we have our general equation, we have the particular solution and the solution set. And the homogeneous solution, the system solution set to the homogeneous system. So this is my particular solution, independent of any free variables. And the solution set of the homogeneous system will have the free variable. So this is my solution set over here. Let's go through another example. Let's go to two more examples. So for this, it's straightforward. We have done it before. So this is our solution set using vectors. And as you can see again, there are no free parameters. This means that the solution set is a one element set. Hence, we only have a particular solution. And since it does not have the factor of 0, this system is not consistent at all. And now let's take a look at the last example, which is this. And just like what we covered earlier on, this is our solution set using vector notation. And to get our solution set using vectors, we just expand all these terms here. So as you can see, this is different from the previous examples we did because now we have two parameters or two free parameters, which is like two non-leading variables. And again, so now you have the particular solution which is independent of any free variables, and the solution set of the homogeneous system is over here because they have the free variables with it. So our particular solution is 1/3 minus 1, 2, 0, 0 as here. And now we have the solution set of the homogeneous system, which is this part here. So we have come to the end of this tutorial. So if you have any details, you can drop me a comment and I will get back to your comment immediately. So for our next lesson, we will learn more about what makes a square matrix singular or non-singular. That's all for our tutorial. Thank you.